I'm Emily, and I'm an educator at MOHAI, and this is Idea Lab at Home. Join us as we tinker, experiment, and create our way through history with rotating topics and activities. Today, we will be exploring computers. Seattle is well known for its history as a hub for innovations in computer technology. Computers have come a long way. At first, they were analog or non-digital, meaning they were mechanical, electric, or electromechanical. Digital computers express, count, and manipulate data using binary, meaning they use only the numbers 0 and 1, or expressions of true and false, and their various combinations. When digital computers were first invented in the mid-20th century, they were huge and were primarily for businesses or institutions, and individuals could sometimes use them at places where you could rent computer time. This is much different than what we think of when we think of computers today. The first PC, or personal computer, wasn't invented until the 1970s, and it's this box right here, the Altair 8800. And you can see it's basically just a bunch of switches and has to be manually operated. Bill Gates and Paul Allen saw the Altair on the front of this magazine cover and decided that they wanted to write a software for it so that you could operate it digitally and faster. At this time, computers use a programming language called Beginner's All-Purpose Symbolic Instruction Code, or BASIC. And Gates and Allen devised a system so that a person could provide input to the Altair via teletype keyboard, and the computer would give an output on paper tape. Computer company IBM saw this and hired Gates and Allen's company, Microsoft, to create software for a PC with a keyboard input and display output. This one. This contract helped launch Microsoft into the company that we know today. Now, there are all sorts of programming languages that programmers can use to tell computers to complete all kinds of complex tasks. And with artificial intelligence, programmers can even teach computers to solve problems on their own rather than try to account for all of the possible outcomes of a given task. Let's explore some of the fundamentals of coding and programming. With most programming languages, and especially with BASIC, the computer has to be told exactly what to do or what output to provide given the information or data or input it receives. Remember, the input a computer receives can only be expressed in yes/no, meaning true or false or 1 or 0. For example, we can tell a computer to do one thing if input A is present or true or 1, and we can tell the computer to do another thing if input A is not present or false or 0. And, or, and not are the foundational tools for linking multiple inputs together. Let's try linking two inputs together, A and B. You can tell the computer to produce different outputs depending on whether A and B are present, whether A or B is present, whether neither A and B are present, and so on. A common instruction in programming is the if-then statement. This is when you tell the computer if a condition or input is met or true to produce output X, and if a condition or input is not met or false to produce output Y. An output will continue unless a computer is told otherwise, either because a new condition is met or by discretely defining the output. For example, do a task for 30 seconds or do a task 3 times. You can practice code even without a computer by playing a game with a friend in which one of you becomes the computer. To play this game, you'll need the following things: 2 people, a space, some objects like cones or furniture, and something to write on and with. In this game, one person is the computer and the other is the programmer. The programmer's task is to write code that will get the computer from point A to point B, either around obstacles or by following a specific route using simple code. First step is to set up your challenge course. Define the area that gameplay will occur in, and a start and end point for your computer, plus some obstacles or places they must go along the way. Next, the programmer writes the code, using simple instruction blocks like start and stop, move forward or back, turn left, turn right, using the words until, and, or not, writing if-then statements, and providing units of measurement. Make sure to provide your computer with exact parameters and definitions, like what does one step mean, one turn, or how long to move forward for. Once you're done writing your instructions, run the program. The programmer can read out instructions one at a time, all at once, or pass off the written instructions to the computer. And the computer's job is to follow only the instructions exactly as written. Was your computer successful in completing the task? If not, you'll need to debug your program or fix it to remove any errors. You may need to debug your program a few times to get it right, so keep trying. Once you've successfully written a piece of code, try again with a new obstacle course and take turns being the computer and the programmer. You can locate the activity instructions below or on our website at mohai.org/education. And you can also explore Seattle's computer history with our online collection at mohai.org/collections. Thanks for watching.